All right, grade 10s. A couple things I want to point out before we start this lesson. First of all, in Brightspace worksheet section, you should, I think I've already mentioned it, but if I haven't, a formula sheet you can print off. This is the information you'll be given on assessment, allowed to access. We have on there, as you can see, metric conversion chart, imperial conversion charts, the metric to imperial back and forth chart sets up our proportions. Don't worry about temperature conversions. They're there, but don't worry about it. But today we're going to start talking about shapes and calculations of shapes. Here are the formulas that you are going to need for this unit. Those are the ones that are given to you on that formula sheet, so that's what you'll have access to. If you're doing a calculation and it's not on there, it's because you have to memorize it. So that's the first bit. Make sure that you have a copy of it handy so you access it. The other thing for today's lesson, you were given a measurement unit supplementals page packet as well. So that needs to be accessed. We're going to do some examples out of there as well as out of the measurement booklet. So have the measurement unit supplemental pages packet handy so you can access that. So we're finished conversions. Let's get to calculations. So calculations, let's start with, I believe this is page 25, perimeters and shape names. That's what we're going to look at today. First couple lessons, we're going to focus on two-dimensional shapes. 2D meaning two-dimensional. They're flat. There's things that you draw. All right? When we work with two-dimensional shapes, because you're drawing, you're usually looking at a length and a width for dimensions. All right? When we talk 2D in the real world, floor plans of buildings, they're flat. They're representing bigger three-dimensional things, but the floor plans are 2Ds. Yards and parks, when you have maps of those are 2D, two-dimensional. We're then going to get into three-dimensional shapes, 3D. This is where you add a third dimension, a depth or a height to it. It's things that you can pick up, things in our everyday world, a box, soup can, ball, just about anything in our world. The reason it's 3D, it still has a length and a width to it, but now to give it the third dimension, you can add a height or a depth. Different terms for it, but it means the same thing. So that's what we're going to start looking on. First couple periods, 2D, and then from there we'll go to 3D shapes. Now, shapes, sometimes they'll have particular names given to them, and we'll refer to quadrilaterals, heptagons, octagons, nonagons, whatever. When we have the namings of shapes, it's not just a coincidence that some of these prefixes occur in other situations. So a triangle has a prefix of a triangle, or sorry, a prefix of tri, because there's three parts to it. Like a triangle, three sides, three angles. A quadrilateral, and there's a lot of different quadrilaterals, but quad meaning four sides to it. There's squares and rectangles. Those are all forms of a quadrilateral. Pentagon has 5. Penta. Hexagon. Hexa means 6. Heptagon or hepta meaning 7. Octagon. Octa meaning 8. Nonagon. Nona meaning 9. And decagon. Deca meaning 10. So that's something you might have to recall or call upon later on. And we name polygons based on the number of sides. Just like some items or events incorporate these prefixes. A triathlon There's 3 events in a triathlon. Swim, bike, and run. That's why it's a triathlon. Octopus. Octo, 8 sides. Octopus has 8 legs. A decade. Decade has deca in it. A decade has 10 years. Deca meaning 10. So just a bit of information you're going to have to call upon. All right, 26. Let's talk perimeter. Oh, perimeter. Wonder why I have no hair. It's from pulling it out when we get to perimeter questions. Perimeter is something that you were introduced to back in elementary school, and kids always forget and get stressed out about perimeter. Perimeter is the distance around the outside of an object. All you do to calculate perimeter is you total or add the lengths of all the sides of the object. That's what perimeter is. Imagine walking around the object. Back when I was in elementary school, that's what my elementary teacher told us. Mrs. Barr used to talk about perimeter when she introduced it. Perimeter, you are walking around the whole object. Imagine walking around the object. That's what perimeter is. It's one of those things, kids forget it and mix it up. So, here we go. Not a difficult concept. It's going to be a little difficult because I'm going to make you think. But what's the name and perimeter of the following shape? Well, the name in general is a quadrilateral because there's 4 sides. However, more specifically, this is a trapezoid. Should be familiar with the trapezoid. So that's trapezoid. If I want to get the perimeter of it, I want to add up all the sides. Well, there's 2 ways to write the expression. One way is to add up all the sides. This always kills me. Oh, the distance around is 4 plus 2 plus 7. Why is it 4 plus 2 plus 7? Because those are the numbers there, Mr. McDonald. That's why it's 4 plus 2 plus 7. It's the distance around all sides. It's a quadrilateral. 1, 2, 3, 4 sides. We have to make sure we're adding 4 things. And in this case, we look at the ticks. Oh, look at that. The 2 centimeter is a double tick side like the side across from it. So we have to make sure we add all 4 sides. However, there's a better way to write this expression. We always want to try to write the expression in as compact a form as possible. Because the 2 centimeters occurs twice, better expression for this perimeter would be 4 plus 7 plus 2 sides that are 2 centimeters. Multiple 2 sides, still write it like that. You're going to see an example in a couple minutes that will show you why this is effective. Anyways, perimeter, add it up. 4 plus 2 is 6. 6 plus 7 is 13. Plus 2 is 15. And the distance around an object is just the units that are there. 15 centimeters. Fairly straightforward. If you remember, it's just all the sides around the object. Number 2, Marcel wants to put an ice rink in his backyard. He determines the length of the rink will be 25 feet wide. Will be the length 25 and the width will be 10. What is the perimeter of his rink? He's going to put up some boards or something around it. So it doesn't hurt to do a quick sketch. Okay, the length of the rink, 25 feet. The width is 10 feet. What's the perimeter? So because we're talking length and width, the assumption is it's a rectangle. Opposite sides are congruent, equal. So the best way to write this perimeter, we have 25 feet twice going around it. Plus, we have the 10-foot length going around twice. 2 times 10. There's the best expression. 25 plus 25 plus 10 plus 10. Is that acceptable? Yeah, kind of, sort of. It's at a point now you're into your math where you should be writing better than just 25 plus 25 plus 10 plus 10. Solve it, multiply first. 50 plus 20, perimeter is 70 feet. There's your distance around. Pause the video, take a look at example 3, try it, and then come back and we'll do it together. Go. All right, so hopefully you've finished it. Frank, building a fence around his property. Again, length of the property is 84 feet. Width of the property is 80 feet. When we're talking direct length and width, we can assume it's a rectangle. Now it talks about this 8-foot pieces. The panels are going to go around, but before I know how many, I need to figure out what's the perimeter, and then the perimeter is going to be split into these 8-foot chunks. So it'll be perimeter divided by the 8-foot panels. But first, perimeter will be 2 lengths that are 80 feet, the ends if you want, plus we have 2 84-foot lengths making up the perimeter. That accounts for all 4 sides. So the perimeter will be, when we add this up, 160 plus 168, which is 328 feet, is the perimeter. Distance around is 328 feet. But we want these 8-foot panels, so all of that 328 feet needs to be split into 8-foot chunks. So we're going to divide it into 8-foot chunks, and that's going to tell us that 41 panels are needed to go around the, that's not perimeter, sorry, perimeter is 328. I should have written this separate. It's not perimeter. 328 divided by 8. That tells us 41 panels are needed around the property. So those are fairly straightforward. That's what perimeter is. But let's go to our supplemental pages. Pull out supplemental pages and go to page 3 to start with. On page 3, we have perimeter calculations. It says to solve for the perimeter of each shape, include a simplified expression first. So let's take a look at number 4. I want to figure out the perimeter of that E, I guess. But there's a couple things we have to be aware of. Take a look at it. Is there anything that jumps out at you? Well, we have multiple sides of the same dimension. We can identify with the ticks. But also, note that we have millimeter lengths, but we also have decimeter. I can't combine different units. My suggestion is always to go to the smaller unit because you can hopefully eliminate decimals. Because if I want to go from decimeter, if you think of the metric conversion, decimeter will go down to centimeter, will go to millimeter. Decimeter to millimeter is the decimal goes twice to the right. So if I move my decimal twice to the right, I'm working with 50 millimeters. Look at that, the decimal's gone. So converting to the smaller unit will often get rid of decimals. Is there anything else you notice about this particular diagram that's going to cause us grief? Well, if I look around, I have to total all the sides of it, and I don't have a dimension here. So we have to use the other parts to see if we can find it. Well, we want to go all the way from top to bottom. Are there any values that help us go top to bottom? Look at this. That 23, there's another single tick 23, and another single tick 23. But we also have these two here, single tick 23s. These 5 lengths are going from top to bottom. So I know that this length here is also 23 millimeters times 5, which means I have 115 millimeters for my length on that side. So lots going on in this question, but this is the type of question you have seen before. So break it into these parts. Now, we have lengths for all the sides. We have the same units. Let's come up with a formula or expression for perimeter. Perimeter, 115 millimeters is one side. Then I have the triple tick side, which is 50. Well, look at this. I have two of those triple tick sides. So my 115 is going to be increased by two 50 millimeter sides. What else do I have? Well, I'm going to keep walking around. Oh, I have a single tick side. Well, I'm going to count up. 2, 3, 4. I have 5 single tick sides, which are 23 millimeters. So there's another calculation. Well, we still technically haven't walked around the whole thing because I have 1, 2, 3, 4 double tick sides that are 32 millimeters. So 4 times 32. There's what we're looking for a simplified expression. Otherwise, I'd have to have 12 numbers all written out being added, which isn't good math habits. So what do we have? We have perimeter is 115 plus 100 plus 115 plus 128. And when I add all of those up, what do I get? I believe, I'm doing this without a calculator, so you might want to check my work. 458 millimeters. Yep, I'm pretty sure that's what it is. 458 millimeters. Single expression, a little tricky. That's what you should be able to do. If we take a look at page 4, number 8. Now these questions, which you're going to be expected to do, a little bit more involved because they have some algebra. The reason they have algebra on them is if we look at the instructions at the top, it says solve for the unknown dimensions on each shape. Because this time, let's take a look at number 8. We see with number 8, the perimeter is given this time. Well, if perimeter is given and we have an unknown side, I still want to start with that expression. But this time, instead of putting perimeter equals, well, we now know what perimeter is. So we can put our perimeter in, 231, and now write the expression. What do we have? Well, we have an unknown length, which I will call x. We have a 48 millimeter side. We have two single tick sides, which are 34, so two 34s, and we have a final 42. So I still write a simplified expression, but this time I have an unknown x because I know perimeter. And now this goes to algebraic solving. Solve for x. What are you going to do to solve for x? Multiply if you can first. 231 equals x plus 48 plus 68 plus 42. Next step in solving, combine your like terms that are on the same side. Well, I have those constants. So I have a 48 plus a 68 plus a 42, and I got 158 there. So we have 231 equals x plus 158. And now I want to solve for x. Well, how do I get x by itself? It's attached by addition to the 158, so I subtract 158 from both sides. And the 231 subtract 158 gives me a value of I got 73. So X is 73 millimeters. So these sorts of questions, these 2 pages, which will be part of your assignment, are what you should be looking at, focusing on. Great questions to make you think. All right? Make sure they get done when it's assigned. Because we got one more little bit to do. Let's go back to the regular booklet. The regular booklets now. Go back to where we were. Let's move now, after perimeter, to page 29 and deal with circumference of a circle. Because circumference of a circle is just circumference being a fancy name for perimeter of a circle. So that's what we're looking at doing with circumference. Circles are special because they're curved edges, so we want the perimeter. First thing, remember, with a circle, 2 important values. Well, more than that, but right now, we have a diameter which goes across the middle. Distance from edge to edge going through the middle is the diameter, and the radius is from the middle to the edge, but not all the way across, which is your radius. So diameter is all the way across, radius is half. The radius could be calculated by taking the diameter and splitting in 2. If I have a diameter, half of it is the radius. So diameter divided by 2 is the radius. And if I don't have the diameter but the radius, 2 radiuses, 1 radius and 2 radiuses would make a diameter. All right? Basically, this formula is all you need to know. Well, there's 2 of them, really. The circumference, perimeter of a circle, is pi times d, or 2 pi r. Don't forget, pi, special number that deals with circles. 3.14159 ... Usually a lot you will use 3.14. You should use the pi button on your calculator, which we'll take a look at in a sec. So, circumference equals pi d, where c stands for the circumference, what we're trying to calculate. Pi is 3.14, but we should use the pi button if we can. D is diameter, and r is radius. Which formula you use depends upon what's given to you. The reason there's 2 is that pi times d, well, what's another way? What's the diameter? We just said the diameter is 2 radii. So I could write this as pi times 2 radiuses and just rearrange it, 2 pi r. They mean the same thing. They both represent circumference. So you can use whichever one you want depending upon what's given to you. So if we want to complete this chart, well, radius is given as 10. What's your diameter? The diameter is twice the radius, 20. What's your circumference? Well, we could go pi times d or 2 pi r, whichever we prefer. Let's take a quick look with our calculator though. On our calculator, if I want to go 2 pi r, circumference would be 2 times, take a note, might be hard to see on the calculator, the little button or the blue above our exponent button. I get that by hitting second function. I can go 2 times, if I go second function in that, it puts the pi symbol, so instead of using 3.14, we're going to use the actual all of pi value. And then times the radius, which we said was 10. Our circumference around that circle is 62.83185, blah, blah, blah. Rounding to 1 decimal place, 62.8. If you wanted to do pi times diameter, should get the same thing, same circle. Pi would be second function exponent button to get the pi times the diameter, which is 20, and we get the same thing. Either way, but you should get in the habit of trying to use the pi button. We get a final value, circumference 62.8, and that's centimeters. This time, diameter is given, so the radius would be half of that, because diameter is all the way across, radius is just half. Circumference, pi times 14 would be one possibility, or we could do 2 times pi times the radius of 7. Either one will work, whichever works for you. In this case, I get 43.9695, which rounds up to 44 centimeters. Now the last one's a little different, because the last one gives us circumference. Well, this is again where some algebra comes into play. Start with your formula. Circumference is pi times d. Well, what do we know this time? This time we know that circumference is 35. Pi is pi. We're trying to find the d. So if we're trying to find d, we have to isolate it. What do we have to get rid of? The pi. How are these two attached? By multiplying. So we divide by pi on both sides. And when I do that, I'll have an answer that equals d. So that's what we're looking at doing. 35 divided by pi. Let's pull the calculator back up. This time we want 35 divided by second function to get the pi, and 35 divided by pi, 11.14, or 11.1 rounded to 1 decimal place. So we end up with d equal to 11.1. Now note that we use this formula, so we got the diameter, 11.1 centimeters. Which means, how do I get radius? Radius will be half of the diameter. Half of 11.1. Double check it. I'm pretty sure I know it, but I don't want to make a bonehead. We get 5.6 rounded centimeters. So we can solve for an unknown by using an expression, equation, and a little bit of algebra. Let's take a look. What is the circumference of a circle with a diameter of 8? Well, if the diameter is given, circumference is pi d. Start with a formula. Substitute in. Circumference is pi times 8. So we can just go pi times 8 on our calculator and get 25.1 centimeters. What is the circumference for the next one of a circle with a radius of 2.5? Well, if we have a radius given to us in this case, I'm not going to use pi d. I have a different formula that incorporates radius, 2 pi r. So circumference is 2 times pi times the radius 2.5. 2 times pi times 2.5. I got circumference is 15.7 millimeters. Number 4. The circumference of a circle is 52. So we have to be careful here, because this time circumference is given. We need to know diameter. Well, we want diameter. Circumference is pi d. There's my formula. But this time, 52 can be put in for pi, and we don't know diameter. If we want to solve for diameter, we want to get it by itself, get rid of pi, by dividing, and our diameter, 52 divided by pi, works out to be 16.6 centimeters. So circumference of a circle, special formulas to use, but circumference of a circle is just the perimeter of the circle. Different than straight up straight edges, but still manageable. Let's go back supplemental pages and take a look at one more example from there. Page 7. Page 7, where are we going to? There we go. Circle questions. It says to solve for the perimeter and area of each. Well, we'll solve area later. Let's just focus on perimeter today. If I want to get the perimeter of question number 1, perimeter of question 1, I want to walk around it. Still thinking that way. So what makes up the perimeter? Well, the perimeter has 2 double tick sides. So I have 2 80 centimeter sides. It has 1 90 centimeter here, plus 90 centimeters. What else do we have? Well, we can see we have 2 single tick lengths. If I were walking around this, I have 2 15s. But I also have, what haven't I walked around yet? I haven't walked around this curved part. Now the curved part is not 60 centimeters. The curved part is half a circle. So I need to incorporate a formula somehow for half a circle. Well, I'm going to rewrite this. 2 times 80 plus 90 plus 2 15s plus. How would I get the whole circle? Let's imagine that we're walking around a whole circle here. What does that 60 represent for the whole circle? Well, that 60 is the same as the diameter as if I walked around a whole circle. So that's going to help us. That 60 is important. It's the diameter for the whole circle. So that's a D value. But I don't have a whole circle. I have a diameter, so I could say pi times diameter because I have the D value, but I don't have the whole circle. I only have half of it. So I can divide it by 2. And what can I put in for a D? Our D is 60. So I can convert this equation to 2 times 80 plus 90 plus 2 times 15 plus pi times the diameter of the circle is 60 if it was a whole circle, but I want to divide by 2 because I only have half of it. So perimeter equals 160 plus 90 plus 13 plus pi times 60 divided by 2. Pull it up on our calculator. We have pi times 60, second function, get pi, times 60. And what do we want? We want to divide that by 2 because we're only walking around half of it. 94.2 plus 94.2. So we can do uglier circle questions, but it requires a bit of thinking. Fair game for your assessments though. You need to practice these. So when I combine all those, the 160 plus the 90 plus the 15 plus the 94.2, my perimeter of that first shape is 359 2/10 centimeters. And there you go. So everything perimeter, including circles. There it is. That means you need to do some work, please. So your assignment, is going to be, I got to find somewhere to write it. Here we go. Your assignment, and it's got lots of pieces, but they're not all really complicated. Booklet, page 27 and 28. That's your start. Then, in the supplemental handouts, supplemental pages, page 3 and 4. This is the work that deals just with straight edge shapes. Second part to this assignment is the booklet that you work in all the time, page 30 and 31, and then supplemental pages, page 7. Finish it. I guess number 2 and 3 because we did number 1 and we did number 1. But only do perimeters on that because we haven't talked area. That's your assignment, perimeters. Gonna see it in questions forever. Perimeters always something that gets worked with. Practice it and have fun.